Okay, let's talk about molar mass. All right, folks, okay? So I'm going to calculate the mass of 1 mole of methane. So this is a molecule. What kind of molecule is it? Ionic or covalent? This one's tough. Okay, hopefully you said covalent. 2 non-metal atoms, right? Look at your table. Carbon and hydrogen are both non-metals. So this is covalent. It looks something like this. A carbon with 4 hydrogens all surrounding it. That's natural gas methane. Okay? Well, we would see from the periodic table that the mass of 1 mole of carbon is 12.01, right? The table tells us 12.01 AMU. But we recognize that's the same thing as 12.01 grams per mole. I know in the last slide, I was more precise. I used 12.011, but it's fine. 4 sig figs is totally fine for this. Okay? So the mass of 1 mole of carbon is 12.01 grams. Well, the mass of 1 mole of hydrogen on the periodic table, hydrogen is 1.008 AMU, which is the same thing as 1.008 grams in 1 mole. Okay, so look, check this out. If I say times 4 moles, because there's 4 of these things, then the mole and the mole cancel, and I get the total mass of how many moles of hydrogen I have, in this case times 4. And then now I add all of this up. 12.01 plus 4 times 1.008 gives me 16.04 grams for 1 mole of CH4. Okay, and we could say then the molar mass of methane, I'm going to write it as 16.04 grams per mole. Okay, and right by saying gram per mole, right, that's implied that it's gram per 1 mole. And so let's just back up for a second. Let's remind ourselves what's happening with this thing. Okay, in 1 mole of methane. So in 1 mole of methane, there's 1 mole of carbon, and there's 4 moles of hydrogen. Okay? So don't let that confuse you thinking like, well, but 1 plus 4 equals 5. Why is it not 5 moles? And it's kind of like the same thing as saying like, I'm 1 human body, but I have 2 arms. It's the same thing, right? So I'm not like making up a bunch of body parts or whatever, making up new mass, right? Saying like my body contains 2 arms is just like saying 1 mole of methane contains 4 moles of hydrogen and 1 mole of carbon. Because if I was making methane from its elements, I would need a ratio of 4 to 1, 4 parts hydrogen to 1 part carbon. So don't forget that law of definite proportions, right? We talked about that in the last week's lecture, okay? Methane is 4 parts hydrogen to 1 part carbon in terms of moles. Now, in terms of mass, obviously you can tell the mass ratio is different. And we're going to talk about percent mass soon, okay? Okay, calculate the molar mass of the following substance. Calcium phosphate. Sorry, I blanked out there on the naming. So PO4 is phosphate. And calcium, no Roman numerals, right? Because we know calcium is always 2+. And let's just review really quick, like how do you get that formula for calcium phosphate, okay? So calcium is always 2+, and phosphate is always PO4 3-. All right? So look, if I have 2 of these, I'm going to put a 2 in front. Remember, respect the subscript, respect the coefficient, okay? So if I have 2 of these, that gives me 6- charge in total, right? And if I have 3 of these calciums, that gives me +6 charge in total. The +6 balances the 6-, and thus my formula for calcium phosphate as a compound, it has 3 calciums, which means when I'm writing this as a formula, that 3 now has to become a subscript because that tells me there's 3 calciums bonded to every 2 phosphates. Even though when I break this thing up, if I were to dissolve calcium phosphate, I would have 2 individual phosphate ions for every 3 individual calcium ions. Okay? So remember, respect the subscript. Remember what the subscript means and what it tells us. So now how do we calculate the mass of this? Okay? Well, I know that I need 3 times the mass of calcium. When I look up the mass of calcium on the table, I get the average mass, right? 40.078 grams in 1 mole, okay? I know that I need now, so what am I gonna do here? Because I have 2 of these phosphates, but 1 phosphate is PO4. Well, so for every 1 phosphate, I have 1 phosphorus. For every 2 phosphates, I have to have 2 phosphoruses. Okay, so that's 2 times, and then now the mass of phosphorus is 30.974 grams per mole. Okay, but now for every 1 phosphate, I have 4 oxygens, which means for every 2 phosphates, I need 8 oxygens. 2 times 4 gives me 8, or even I could distribute it there. 2 times 4 gives me 8 oxygens. So that's now 8 oxygens, and the average mass of oxygen is 15.999 grams per mole. When you're doing molar masses and atomic masses, I think you should definitely keep as many sig figs as you can because they're available, right? We have all of the sig figs on the periodic table, but then you might be adjusting the number of your sig figs later based on how much maybe mass you actually used in the lab or whatever your limiting significant digits are, okay? So now we take 3 times this, plus 2 times this, plus 8 times this. The 3, 2, and 8 do not have any sig figs, but since here I took 3 decimal places for all my sig figs, I'm gonna have 3 decimal places in my final mass, and from this I get 310.174 grams per mole for calcium phosphate. Make sure you can do this, and you have to be able to do this for any formula that I give you. I'm not going to make you memorize the masses, right? But you still have to know where to find them, how to look them up, and so on and so forth, okay? We're going to have lots and lots and lots of experience and practice doing molar masses. So this is the only example that I'm going to walk you through here. And once you start to get good, you'll just be able to like fly through this on your calculator, I hope. Do you know what I mean? Like if you need to write this out for now, that's okay. But I want you to really practice just being able to quickly access the periodic table. Okay, 3 times this, plus 2 times this, plus 8 times this, right? Boop, 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 boop. Just be able to do it like that. So practice. I understand you might not be able to do it fast yet, but I want you to be able to fly through a molar mass calculation and also make sure that you're still doing it correctly, right? Quickly and correctly. So you might be slow for now. That's okay.